All right. All right. So there's our mean, median, and mode. All right. Weighted average is another type of mean, but it's calculated by using frequencies of data values. So here we have, suppose there are 30 movies are rated as follows. So there was 8 movies that had a rating of 4. 12 movies had a rating of 3. 7 movies with a rating of 2, and 2 movies with a rating of 1. And then there was actually 1 movie that got no stars. Okay, that would be Grown Ups 2. Right. Or some other movies. Right. So to find the weighted average, we just multiply the frequency times how often it happened. Well, for numerical data, the weighted average of all those outcomes is called the expected value for that experiment. For example, the expected value for the number of stars of a randomly chosen movie from the group above is 2.8. Probability distribution for an experiment is a function that pairs each outcome with its probability. So instead of saying how many movies had that rating, we could say what is the probability of getting that rating. So we could say this would be 8 out of 30, and 12 out of 30, and 7 out of 30, and 2 out of 30, and 1 out of 30. And if we use those numbers, then we can multiply how many stars they got times the probability, and we would get the expected value for what we expect the number of stars to be. So here we have a probability distribution for successful free throws for a practice set is given below. Find the expected number of successes for one set. So this person went to the free throw line, right, shooting free throws. And 3 times out of 20, they made 0 free throws. So it looks like they probably shot either 3 or 5 of them. 1 time out of 20, they made, or 3 times out of 20, they made 1 free throw. 1 time out of 5, they made 2 free throws. And half the time, they made 3 free throws. So this number in the top row is how many free throws they made. This number down here is the probability that that happened. So to find the expected number of free throws they're going to make, then we are going to multiply how many they made times the probability and add them together. That's the expected value. Multiply the number they made times the probability, then add them together. So we have 0 times 3 over 20 plus 1 times 3 over 20 plus 2 times 1/5 plus 3 times 1/2. So it works out really nice because when we're doing expected value, we are going to multiply these columns together, right? And then just add those answers up. So we get 0 plus 3 over 20 plus 2 over 5 plus 3 over 2 when I multiply them together. So I can take my calculator and add them, or do it by hand. If you want to get a common denominator and do it, you can do it that way also. But the answer we give is going to usually be a decimal in this case. Then. So what's your decimal, Mackenzie?
I had 2.0.
Okay. So when this person goes to the free throw line, we expect that, I don't know how many she shot, whether it was 3 or 5 or whatever, but we would expect that this person is going to make 2.05 free throws every time they do that set of free throws. So more than likely, it's probably like a set of 5. This person is just an average free throw shooter. Not great. They're only averaging 40% if that's the case. So expected value, we take the number of things that happened, multiply it by the probability, and then add them together. So for expected value, multiply the number of times something happened, multiply by its probability, and then add. All right. Box and whisker plots. How many of you remember making box and whisker plots? Okay. For box and whisker plots, we need 5 important numbers. Okay. And this is actually, has an actual name to it. This is called a 5-number summary. So we need to know the min and the max, the median, and then the first quartile and the third quartile. Those are the 5 numbers for the 5-number summary. And also we're going to find what's called the interquartile range. And the interquartile range is basically the length of the box. Okay? The IQR we call it. But it's the distance from the first quartile to the third quartile. And so just the distance or the length of the box. What the quartiles are the medians for the lower half of the data and the upper half of the data. And one of the things that I have to remind students of is that whenever we put a box plot, we make a box plot, we put a number line, and then the box plot goes above the number line. It does not sit on the number line. Okay? All right, it's not below it. It's above it just like it is here. All right? Above the number line. Okay. So to make our box plot, first of all, we need to take our data and order it from least to greatest. So we have 2, 4, 6, 8, 9 numbers here. We're going to order them from least to greatest first. So we know the min is 4 and the max is 10. All right, because we want to find those 5 numbers. The median in this case is what number? What's the median? So there's 9 numbers, right? Okay, so the middle number is 7. So the median would be 7. So here's the median. Right? So to find the quartiles, right? To find Q1 and Q3, we need to take the lower half of the data and find the median of that, and the upper half of the data and find the median of that. So we look at the lower half of the data, which is just the numbers 4, 5, 6, and 6. And we need to find the median of them. So Q1 would actually go right here between the 5 and the 6. So what's between 5 and 6? So I just find the average of those two numbers. Okay, the average of 5 and 6 is 5.5. So Q1 would be 5.5. So whenever you have an even set of numbers and you're trying to find a median, it's the average of the middle two numbers. So then Q3 would be up here, and that would be the average of 8 and 9, so 8.5. And we can do the IQR right now also. The IQR, or interquartile range, right? That's just the distance from Q1 to Q3. So just like for the range of data, we take max minus min. For the interquartile range, we take Q3 minus Q1. So this would be 8.5 minus 5.5. Which is 3. Okay. So the IQR is 3, which means that the width of my box for my box and whiskers plot is going to be a length of 3, from 5.5 to 8.5. All right. So we'll make our plot. Oh, look at that, nothing there. Okay. All right, so we need a number line. Okay, so really on this number line, all I need is the numbers. On your number line, you just need the numbers 4 through 10, or 3 to 11, is what I would do. Okay. I would make it from 3 to 11. So you have one number below the min, one number above the max. So we're going to put a dot or a short vertical line at the min of 4 and the max of 10 to represent our min and our max. And then we'll make longer vertical lines at Q1, Q3, and the median. And connect them. So whenever you make a box plot, right, you need to share all these numbers. Okay, you need to have the 5-number summary plus the IQR. And your box plot must be above the number line like it is here. Right, and reasonably accurate. Now, when we are working with sets of data, it's important to know the mean and the median. And one of the things, if you go on to do statistics, we talk about a couple other things. We talk about variation and measures of variation. And there are two different measures of variation. One is called the standard deviation, and the other one is actually the IQR. So we tend to use the IQR works with the median, and standard deviation works with the mean. And so if you take a statistics course, you'll talk about when I should use those two together and when I should use the mean and the standard deviation, or when I should use the median and the IQR together. So measures of variation basically tell us how spread out the data is. Okay? Like our IQR on that last box plot was 3, so that really tells us that all that data is pretty close together. Now, and that's what standard deviation tells us also, is how spread out data is. And so we're actually going to use our calculator to find the standard deviation, which is denoted with the symbol here called sigma. That's the lowercase sigma. Okay? We'll actually use the uppercase sigma in chapter 12 doing summations. And then when we square that, it's called the variance. So we have the standard deviation and the variance. And that's why in the mean we use X bar to denote the mean. So we're going to take this set of data, and I want you to put it in your list on your calculator. So remember, that's stat and edit. Okay, so we put the data in our list. And remember how we found the regression? When we were doing regression from lesson 6 from chapter 9, we went to stat and then over to calc. And we have all these regression things here. Well, we don't want the regression in this case. We're going to do one variable statistics, number 1. Okay. One variable statistics, and just hit enter. Right? So when you know where's our information at, our information is in list 1. In the frequency list, you don't need to worry about that because we already know they're all just 1, and calculate. So here is our mean. It's 7. This next thing tells us the sum of all the numbers. Okay, so we had 9 numbers. They add up to 63, so 63 divided by 9 is my mean of 7. Okay. This next thing tells us what happens when we square them, and then we have standard deviation. There's 2 types of standard deviation. We're going to use sigma. Okay, all right. There's a big S. One stands for a population, a whole population. One talks about just a sample of a population. So we'll be using sigma here. So for this data we have here, this information here, so they want us to find the mean, the standard deviation, and we're going to find the variance. So the mean, X bar equals 7. The standard deviation is denoted by sigma, all right, like a little circle with a tail at the top, and that's 1.83 in this case. Okay. And to find the variance, we just take that number and square it. And make sure you use more than just those 2 numbers when you're doing it, okay? So 1.8257 at least, and then square it to find that number. But also, if you scroll down, there's your 5-number summary. So what did we do? Put the data in our list. then the stat, calc, and one variable statistics. Data in our list. Once the data is in our list, we go to stat, calc, one variable statistics, and this gives us, at first, it tells us the mean is x bar, sigma tells us the standard deviation, and if we scroll down, we have our 5-number summary, min, max, Q1, Q3, and the median. So a fast way to find them. Okay. And the last thing we're going to talk about is what's called outliers. And there are, for outliers, they are extreme numbers that are much larger or much smaller than other numbers. Usually, we can tell an outlier pretty easily because they are so far apart. Okay? It's kind of like in our warm-up. We had that group of numbers 1, 2, and 87. Okay? 87 was so much larger than 1 and 2, we would say it's an outlier because it's way away from the rest of the data. Well, there's two different ways you can find outliers. One is using the mean and standard deviation. And the other way is using the quartiles and the IQR. So when you're talking about the mean and standard deviation, we say that things are outliers when they're more than 3 standard deviations from the mean. In other words, if we take the mean and add the standard deviation 3 times, any number larger than that would be an outlier. If we take the mean and subtract 3 standard deviations, then any number smaller than that would be an outlier. And then they have a different formula here they use for if we're going to do quartiles and IQRs. So it looks like this, basically. That if I have, here's my number line here. Here's the mean. And I have 1, 2, 3 standard deviations here. And 1, 2, 3 standard deviations here. All right, then anything this way or that way, we would say those are outliers. Right? So if I add 3 standard deviations to the mean or subtract 3 standard deviations from the mean, so anything outside of that area, we would say that would be an outlier. And it depends on the situation which one of these you actually use. Okay? And if you take statistics class, then you would figure out, we'll know when we should use one versus the other. All right. So here's a set of data. I'll move it down. Oops. All right. So we're going to take this set of data and we're going to figure out which ones are outliers from this group. So what I would do then is, since they're all 92 point something, okay, is I would, if I'm putting these in my calculator, I'm just going to put the decimal point numbers in, okay, instead of typing all the rest of them because they're all the same. But if you look at these numbers, right, which number do you think would be an outlier? Okay, 92.1, because all the rest of them are 92.7, 92.8, and 92.9. Right? So that one's probably an outlier because it's way away from the rest of the data. Right? But we're going to show how that is true by actually doing some calculations. So the first thing I'm going to do is I'm going to put that list of numbers in my list. And like I said, in this case, since they're all 92 point something, I don't need to use the 92. I can just put that last number in. Just remember that we're talking about anything I get is going to be a decimal point from there. All right, so 8, or excuse me, we better use 0.8, 0.9, 0.7, 0.7, 0.9, 0.8. Right. So we go to stat, calc, one variable statistics, because we want to find the standard. We need to find the mean and the standard deviation. All right, our data is in list 1. So the mean in this case is 92.77. And the standard deviation is going to be 0.195. Okay? So the mean, x bar equals 92.77, and standard deviation is 0.195. So what we're going to do then is we're going to take 92.77 and add 3 times 0.195. That would be our upper limit for an outlier. And take 92.77 minus 3 times 0.195. And that would be our lower boundary for outliers. Okay? Yes? Because that's the number that we use. Okay? 3 standard deviations is the number that we set for that. Okay? Right? So any number larger than 93.355 would be an outlier, and any number smaller than 92.185. So according to how we find outliers, 92.1 is an outlier because it's smaller than this. It's not much smaller than it though, okay? But it is an outlier. So 92.1 is an outlier. Because it is more than 3 standard deviations away from the mean. So we find the mean, find the standard deviation, do the mean plus 3 times the standard deviation to get our upper limit for outliers, and the mean minus 3 times the standard deviation to get the lower limit. So anything above 93.355 is an outlier. Anything below 92.185 would be an outlier also.